planet orbiting Proxima Centauri is the nearest exoplanet we will ever find because it is the nearest star to the Sun. What the James Webb Telescope found that no one expected was city lights in space, 7 trillion miles from Earth. This amazing discovery has made people wonder if there is life on other planets. The telescope focused on Proxima Centauri b, which is the nearest star to Earth, and showed that it was giving off strangely bright lights. What could be making these lights on Proxima Centauri b look like city lights? Could this be a sign that there is life beyond Earth? Come with us as we look into how the James Webb Telescope found these strange things in space. Scientists and people in general have been waiting and studying for years to catch a glimpse of life outside of our solar system. Any proof that this space fantasy is true has been received with open arms. Scientists got the biggest surprise of their lives not long ago when the James Webb Space Telescope saw solid proof that there are living things in space. The telescope was looking into space and sending important data back to Earth when it saw strange lights that looked like they came from the world Proxima Centauri b. These lights looked like they were lighting up a faraway city. Scientists are shocked at the thought of an alien city possibly existing on Earth. Each of them is confused because this life seems to be the one they've all been waiting for. If this turns out to be true, it means that intelligent life forms in space are running societies that are very different from what humans know, and we're just now finding out about them. When NASA engineers look at the city lights 7 trillion miles away from Earth, they can't help but wonder how long these lights have been there, waiting for people to make the technology to see them. David Kipping, a scientist at Columbia University, says that the Proxima b exoplanet is hard to understand because it has city lights. He said that because the heating patterns in this star system are different from those on other worlds, it is known that most rocky planets take in sunlight and give off infrared energy. But not for this world. Its infrared nature is very different from that of its star, which is called Proxima Centauri. The James Webb Space Telescope (JWST) was able to make a good study with this. It was the right tool for the job. Infrared bands are easy for the JWST to pick up. The unique heat signature of Proxima b will help us learn a lot about the atmosphere of other planets. Because the JWST has the most up-to-date infrared imaging equipment, that will be possible. Scientists hope to use the telescope to find out more about the mysteries of this planet's atmosphere. They also want to find out if it's possible to live on this extrasolar world. With its infrared sensitivity, the James Webb Telescope is ready to find out what happens at night on Proxima Centauri b. Most space cameras have trouble picking up the faintest rays of light in the vastness of space, but the JWST can see even the tiniest rays of light from space. It's the perfect tool to find out if the reports about city lights on the night side of Proxima b are true. All man-made lights in the universe can be picked up by the telescope as long as they are within a frequency range 1,000 times smaller than sunlight. The way Proxima b's stellar features combine with its surface is very interesting. On the day side of the exoplanet, there are a lot of solar screens that collect the star's beaming energy. Its spectral edge also bounces light back into space. When Proxima b finishes its circle around its host star, Proxima Centauri, it has day and night cycles like we do here on Earth, with the sun heating up the day and cooling things down at night. It is known that the planet's temperature changes because of what it is made of. In this case, Proxima b will have a huge difference between day and night if it doesn't have an atmosphere. If it weren't for the seas and gases in the atmosphere, the day side would be as hot as a black body and the night side would be completely dark and freezing. Astronomers are very interested in studying how much the temperatures change in order to learn more about Proxima b's atmosphere. The JWST can quickly look at the planet's heat emissions, giving us useful information about its atmosphere thanks to its unmatched infrared imaging abilities. It's interesting that the James Webb Telescope's orbit around the Earth lines up with Proxima b's orbital period. This means that its day and night periods can be fully observed in 11.2 Earth days. Since Proxima b probably has an atmosphere, the next step is to look at the chemistry of that atmosphere to see if it can support life. Gases like oxygen, water vapor, and methane are important signs that a place is habitable. If these elements are found on the planet, it might mean that it has conditions that make it livable. But scientists have to pay very close attention as they record and study light rays as they pass through the planet's atmosphere in order to figure this out. Even though the JWST is very good at describing the atmospheres of planets, it is not very good at finding bound oxygen, which is a key sign of life. Even with these problems, the camera can still look for other things in the atmosphere like ozone, which also shows signs of life. Another important thing to keep in mind is that the James Webb Space Telescope can only look at a few of the closest livable worlds to Earth. Astronomers are looking forward to ground-based telescopes like the Extremely Large Telescope (ELT), which will start working in 2028, so they can do a more in-depth study of the atmosphere. The ELT will be able to look more closely into the atmospheres of faraway exoplanets, gathering information that will help us understand how habitable those worlds might be. Until then, the James Webb Space Telescope is still an important tool for us to use as we try to figure out what strange things happen on faraway exoplanets. Even though it has some problems, the Webb telescope could still change the way we think about exploring other planets both now and in the future. The main goal for future space telescopes is to cut down on the bright light that comes from a planet's host star. This will help scientists see the planet's faint light reflections better. To do this, they plan to use internal masks or big external satellites that look like shields, like how you cover your eyes from the sun to see things better. Future telescopes will be able to study faint light reflections from faraway exoplanets better because host stars will give off less bright light. This will allow for a more in-depth study of their atmospheres and their ability to support life. However, this process has some problems, such as the need to tell the difference between gases made by living things and gases made by natural processes like volcanoes. Astronomers are still driven to learn more about exoplanets and tell the difference between real signs of life and false ones. The Webb telescope's work on exoplanets gives us a sneak peek at the amazing findings that are still to come in science. As our exploration of space continues, we learn more about how the world works and where we fit in it. Scientists have been looking through space for decades but still haven't found solid proof of life beyond Earth. However, the search for other kinds of life goes on. People have been wondering for a very long time if they are the only ones in the world. Today, scientists use the James Webb Telescope to look for signs of life on other planets and hidden alien societies. This question has been around for a very long time. A common story says that aliens are waiting to be found out there in the stars. The Search for Extraterrestrial Intelligence (SETI) Institute was founded in 1984 by Jill Tarter and Thomas Pearson, two American scientists, to look into this idea. SETI is a non-profit group whose mission is to search the universe for radio messages coming from space. Radio waves are interesting because they can go over long distances without getting lost or swallowed like some other types of radiation do. Even though SETI has been looking for over 30 years, they have not yet found any such signs. Jill Tarter, on the other hand, is still hopeful and hopes that new technology will help speed up the search. She thinks that new findings will be made if everyone in the world is allowed to join the search for alien friends in space. Also, NASA has recently said that the James Webb Space Telescope may have seen city lights from a world close to Earth. The JWST is the best way for people to learn about the universe because it is meant to find out details that are hard to find about galaxies, planets, stars, and how space formed in the beginning. With its stellar camera and filters, the telescope separates certain wavelengths of light, which lets scientists study the chemical and physical makeup of faraway heavenly objects. The Webb telescope is always looking for tiny signs of life in the atmospheres of other worlds. This helps us figure out some of the universe's most interesting mysteries. One of these mysteries is the finding of more mass in the world than was thought before. This mass, which is hidden in very large galaxies, makes us wonder more about the shape and size of the early universe. 20 years ago, people didn't know much about the universe outside of our solar system. Astronomers have now found more than 4,000 exoplanets circling faraway stars. This shows how far our interest in technology can take us. NASA thinks that these findings are only the tip of the iceberg when it comes to space. According to scientists, there are actually trillions of exoplanets out there that haven't been found yet. Scientists are still searching space, even though they have been doing it for decades, hoping to find alien homes in places where humans have never been. Along the way, there have been times when hope seemed possible. When the Galileo spacecraft went to Jupiter, its spectroscopic device showed a unique set of wavelengths that supported the idea that plants could grow on other planets. Scientists found a biosignature for the first time, which means there is life in the universe. Vegetation Red Edge (VRE) was the name of this biomarker. The VRE finds alien life by looking very closely at how light bounces off of things. With the VRE's help, the James Webb Space Telescope (JWST) hopes to solve the mysteries of extraterrestrial environments by carefully mapping the orbital parameters of planets that might be livable and that live in the habitable zones of their alien parent stars. Once these are found, the VRE can give us important clues for looking for intelligent life beyond Earth, starting a new journey to find out more about the universe's secrets. When sunshine goes through the layers of the atmosphere, the atoms and molecules in these layers take in the broken-up light, which has different wavelengths. Spectroscopic research can be used to figure out what a unique spectral pattern, like a fingerprint, means. As the absorption process goes on, people usually think that the Webb telescope will be able to pick up light from stars as it hits the atmosphere of a planet. Based on what we know so far, The JWST might be the missing piece to figuring out what these worlds' atmospheres are made of. A lot of carbon dioxide, nitrogen, and oxygen can be found in the atmospheres of planets about the size of Earth. It's possible for life to exist on these kinds of planets, but the lack of strange chemicals could mean that there are other kinds of life and technological societies there. Chlorofluorocarbons, CFCs, which are man-made chemicals used for cooling and other industrial purposes, could help scientists prove beyond a reasonable doubt that there are advanced societies beyond our solar system. If the JWST finds these man-made chemicals in the atmospheres of exoplanets, it will be clear that there is life beyond our solar system. This gives astronomers new chances to study the makeup of other worlds' atmospheres and look into the small chance that there are civilizations beyond the Milky Way. There are options for life beyond Earth that can't be explained by biology on Earth. People usually think of temperate areas as places where life thrives, but the truth could be much harsher and more complicated. For example, extremophiles, a fascinating group of organisms mostly made up of bacteria, question everything we think we know about where life can thrive. These hardy organisms easily live and grow in conditions that humans would consider very harsh. Extremophiles can survive and thrive in places that are up to 250 degrees Fahrenheit and have a pH level below 3. Their ability to live in the harshest situations is a great example of how long life can last. Because of this, the universe's huge size and variety of settings show that our search for life beyond Earth must be very broad. Planets that look like Earth and orbit stable stars like the Sun are great places to study. Also, thinking about other ways to explore like exoplanets near red dwarf stars, which are very common in the universe, opens up new areas to study. Red dwarfs aren't as bright as our Sun and are usually cooler, but they give us a chance to look into the possibility of life in a wide range of settings. Red dwarf stars live for a very long time, which gives slow, complicated evolutionary processes plenty of time to happen. The James Webb Space Telescope found a new planetary system called TRAPPIST-1, which is an important new finding. The fact that the planets in this system look a lot like Earth and might be able to support life is very interesting. TRAPPIST-1 is a planetary system made up of a dim red dwarf star and 7 rocky planets that circle the star and are similar to Earth. From these 7 planets, 3 have been found to be livable, which means they are likely to have liquid water on their surfaces.